Hi guys, so in this session I am going to discuss about the very important property of the solids, that is a moment of inertia of the plane. In this session I am going to explain about the what is the moment of inertia, what are the factors which are affecting the moment of inertia, and significance of moment of inertia. Then how we can calculate the moment of inertia of the different shapes and the applications, and the important thing is what is the part of the moment of inertia in day-to-day life, and need of the moment of inertia for the engineers. So first, what is the moment of inertia? So this is the measuring distance, measure of resistance to rotation. So here if I am taking this this shape, and this is the mass, and if you want to calculate the moment of inertia, it is the resistance to the rotation. Okay, so here in plane areas, it indicated by the area distributed about the axis. So therefore the moment of inertia for this shape can be given by always we are representing the moment of inertia by the letter I, and either we can using the formula integration of y square into dA, that is depending upon the area this moment of inertia will be getting changed, or it may be integration of x square into dA. So what are the important factors which are affecting the moment of inertia? The first important thing is the density. So if the density of the material is same, if I am taking any composite thing, if the density of the material is same, there won't be any change. So if you want to find the moment of inertia of the different, for an example, some I section or T section, if it is the density of the component of I section, so that is a flange and web, or the components of I section, if it is the same, then very easy to calculate the moment of inertia. If it is the density is different, we have to consider the density also in the calculation of moment of inertia. So if the density is same, we will take only the volume. If the density is different, we will consider the density of the material for calculating the moment of inertia. So then and also the shape and size. If it is a regular shape, there won't be any problem. If it is some irregular shape, we have to consider, we have to split the whole structure into the regular shape, and we have to calculate the first centroid, and then again we have to find the moment of inertia. And also the very important thing is the axis of rotation. So in about the which axis the rotation is happening. So since it is the definition itself, it is given, it's a resistance of rotation. So about which axis, if it is a x-axis or y-axis, about which axis it is the thing is rotating. So the axis of rotation also they depend the important factor which is changing the moment of inertia. And what are the significance of the moment of inertia? So it is used in the bending stress calculation. So in mechanics of solids, it is very important. Here this is some beam, and this is a cantilever beam of length L, and the cross section of this beam is given by, it is a rectangle. So mostly we will use the square or rectangular beam. If it is RC structure, we will use RCC structure. We will use the rectangular shape. Okay, so if you want to find the moment of inertia of this rectangular bending stress for the this rectangular shape, first we have to calculate the moment of inertia. So then only we can calculate the bending stress. So in calculating the bending stress, the very important thing is the moment of inertia, calculation of moment of inertia. And also it is very useful in determining the structural stiffness. So while we were analyzing any structure, the stiffness is very important. Okay, so the structural stiffness also depending upon the moment of inertia. And also designing of beam and and column, it is a very important scenario in designing the beam and column. So here, if I want to calculate the moment of inertia of a particle in a system, so here if I am taking some three particles, the first particle is having the mass of m1, and the second one is m2, and it is a m3, and it is which is situated at a distance from some axis. R1 and R2, R3 respectively. If I want to calculate the moment of inertia, so it will be the mass moment of inertia is nothing but the product of mass into the radius. Okay, so here if I want to calculate that mass moment of inertia, it is the sum of the product of mass into the radius. And this is the mass moment of inertia of the rigid bodies. So the moment of inertia of continuous mass distribution is found by using the integration technique. Okay, so here in this system we will divide the whole the element into the different small element. Okay, for an example, if it is the mass of the body is m, we will split the small strips, that we will take the mass of the each and element is dm. Okay, and the distance is the rx from the axis, which axis it is rotating. Okay, so then the moment of inertia will be calculated by using the integration of the r square into dm. Okay, it is a product of a square of the distance from the rotation, the axis and the mass. Okay, so here it is a rigid body. We will consider the small element. We will assume that the mass of that element is dm. Here where we are using, so it is very important thing when we were designing the beam. So here this is a beam, and here the beam is placed like this. Okay, and the same beam, but it is placed like this. Here the two persons are standing here, and it will create the point load. Okay, but here the deflection in this beam is small, but the deflection in the beam is more. So since when I am taking this is the x-axis and y-axis reference axis, if I am calculating the moment of inertia for both the positions, it will be different. So the calculation of moment of inertia is very important in placing how we should place the beam and column in the position. Okay, and also it is very important in the rotational system also. Okay, so then and the next one is you can see this. So this is the boat which is sailing in the some river or some lake, and here this is a center of gravity, and this is a buoyancy. Okay, and whenever this boat is in a stable, and here the CG and the buoyancy point should be in same. Okay, that is a weight and the buoyancy force which is created by the water should be in the line of action should be in same. Then the boat will be in the stable. But here you can see this in this position the boat is not in stable position. So this is due to that the buoyancy, the point of buoyancy and center of gravity is not, the line of action is in different. Okay, therefore this boat will not be in the equilibrium. Okay, and also here the same thing, that is it is used in deflection analysis. So while we were designing the beams, the deflection analysis is very important. Okay, and also it is not only in designing the what a beam and column, day-to-day life, it is very important. So and the best example is the movement of the satellites, and also the falling of fruits or leaves from the tree, and also this is a dusting of carpet, dusting of some dust from the carpet, and driving along the curved path, and also the seat belt, and falling of coins into the glass. So this is some of the examples. So the everyday day-to-day life, day-to-day activities, the moment of inertia is very important. So knowing this is very important, and as a civil engineer we should know that. So since if you are not understanding the concept of moment of inertia, you can't construct the some stable structure. So the understanding the structural stability, if you are designing any structure, it should be stable. Okay, if it is unstable, then the whole building will get collapsed. So due to that uneven settlement of the building, it will lead to collapse of the structure. And also designing the beams and columns, and predicting the resisting of moment, bending. and on also optimizing the cross-sectional shapes and improving the load carrying capacity of the structure, and ensuring the safety against the buckling, and also evaluating stress distribution, and supporting for efficient structural designing. So for in every thing, the moment of the calculation of centroid and center of gravity and the moment of inertia is playing very vital role. So thank you for listening this video. Thank you.